Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, this is a fun problem. This is good practice turning a word problem into math language. So we're told that we have two particles traveling in the positive. We can just call it the positive x direction, just to keep things simple. We're just told that they're traveling in the same direction. The only difference is that the first velocity is 3 times that of the second velocity. And if you get stuck trying to figure out what the next step should be, it can be really helpful just to write it out in math terms like this and just look at it and see if it helps you think about where to go next. So we want to find what the ratio of the charges are. How in the world are we supposed to find charges from all of this stuff that we're given? We want the ratio of charge 1 to charge 2. And it's also a point to note here that it wants the absolute value of those. This doesn't change anything that we're going to do other than that it doesn't matter now if we have a negative or a positive charge. They're just trying to make it a little bit easier for us. So we want to find this ratio, and all we know is the velocities, the relationship between the velocities. But we do know a function that, or an equation that gives us everything that we're given in the problem, or that involves everything we're given. So let's write down that equation. We have the force. Force due to a magnetic field is equal to the power of the magnetic field, what the magnetic field is equal to, times the charge, times the velocity. And since they're in the same direction, we don't need to worry about angles. Or in this case, it's irrelevant to the problem what the angle between the velocity and the force is, because it's both particles are the same. We just want to find the ratio between these two particles. So we can exclude the sign part of this problem and just use from here. So we have this relationship between the velocities. Other than that, everything else is the same except for the charge. So we have charge 2 and charge 1. So F1 and F2 will be the same. B1 and B2 will be the same. The velocities will not be the same. So we have that those are the same. This is for the particle number 2. Let's write one for particle number 1. We have the force is equal to same force, same magnetic field. We have charge 1 this time, and we have the relationship here. We want to get it in terms of one of the variables we don't know. And we have this relationship, so let's plug this part of it in because we know that V1 is equal to that, just so we have V2 in both equations. We have 3 times V2. Now, since we want to find the ratio, it might be easier to solve for Q in this case. I'm only going to do it for one and then rewrite it. Hopefully you'll be able to do it for the second one. So for this one, to solve for Q, I'm just going to write it over on this side, where you have to divide both sides by B and by V2, which will give us the force divided by the magnetic field and velocity for the second particle. And you'll get the same thing for the first particle. This is charge number 1. You'll get the same thing for that, except for you'll have this factor of 3 here. Now, if we want to find the ratio of charge 1 to charge 2, we would divide the equation for charge 1 divided by the equation for charge 2, which can be rewritten. Just divide the reworked one for this one, solved for Q, divided by this. That'll give us this equation. Q1 divided by Q2 So we'll have the reworked Q1, which is the same as this one, but with a 3. So we have F divided by be 3 v2. All of this divided by this equation. F divided by B v2. And we can see right away, you can rewrite this. Instead of having this in the denominator, you can flip it and move it into multiplication here. Times B v2 divided by F. This might make it a little bit easier for you to see what's going on here. So now we can cancel that B with that B, this F with this F, and this V2 with that V2. And all we're left with is this 3, but it's in the denominator here. So this is 1 over 3, which is our ratio. So the ratio of charge for charge 1 to charge 2 is 1/3. And there you have it.